So let's try one like 54e. This is a definite integral where we're going to use change of variable, which is substitution for definite integrals, basically. So we're looking at the integral from 0 to 1 of this function here. Now, if you could automatically know what the antiderivative of this expression is, that's pretty good. But a lot of times that's not the case. And so we want to show, in this case, even if you do know the antiderivative, which I highly doubt you do, you want to show the substitution that you're using. And so clearly I've got 3x divided by the quantity x squared plus 1 all to the 4th power. So that quantity, that inner function, is typically what we're going to choose our substitution to be, our u, as we call it. Again, I'm using the letter u. You don't have to always use u. Sometimes you can use t or w or other things, especially if the original integral is given in terms of u, you'd have to choose some other letter. So, but we're going to choose u. It's pretty consistent to be x squared plus 1. So my du, the derivative of x squared plus 1, is 2x. So I get du is 2x dx. The way I'm thinking is I've got a 3x dx. So in order to get a 3 here, I need to multiply by 3 halves. So multiply both sides by 3 halves. 3 halves du. 3 halves times 2 is 3x dx. So there's the relationship I need there. There's my substitution. I'm almost there. Notice with definite integrals, we have to change these limits as well. These limits are with respect to the variable x. If I'm changing to the variable u, I need to change those limits. You have to do this. So if x is 0, just plug into this, right? X is 0, I get what? 0 squared plus 1, I get u is 1. If x is 1, I get 1 squared plus 1 is 2 for u. So these are my new limits. My lower limit used to be 0, now it's 1. And I've written that down here. And my upper limit used to be 1, now it's 2. Okay, so whatever that changes. I'm just going to replace 3x dx with what? 3 halves du. And then the x squared plus 1 to the 4th, I'm going to replace with u to the 4th. Okay, so notice everything is now in terms of u. And for definite integrals, unlike the indefinite integrals, I don't ever want to go back to the x variable, to the original variable, because this definite integral, I'm going to evaluate it, right? It's going to be a real number, and I'm done. So you don't need to go back, and you don't have to really, in this process, we actually never find the antiderivative for this function in terms of x. I mean, I could do this problem, just get rid of the definite integral, just do the indefinite integral, find the antiderivative, get that, and then I can answer this question by doing the fundamental theorem of calculus part 1, right? And using all x variables. But why go through the bother, right? When I change to u, I just stay there. Clean this up a little bit, bring the 3 halves out, right? It's constant multiple. I'm left with 1 over u to the 4th, or u to the negative 4th du, right? And now I just use the fundamental theorem of calculus part 1 on the u, right, function. So what's the antiderivative of u to the negative 4th? Well, we do know that, right? That's the whole point. Again, the substitution is going to make this function easier, much easier than what it was. So the antiderivative by the power rule, add 1 to negative 4. Be careful. If I add 1 to negative 4, I get negative 3. So I get u to the negative 3 divided by negative 3 times this 3 halves. The 3 up here and this 3 down here, right? Divide top and bottom by 3, and this just becomes negative. 2 is in the denominator. The u to the negative 3 becomes 1 over u to the 3rd power. So here's my antiderivative for 1 over u to the 4th. 3 halves, rather, 1 over u to the 4th is this. And now I evaluate it at the upper limit of 2. So I plug in 2 for u and the lower limit of 1 for u. So notice these are the u limits, right? So we changed over to the u limits here. So we're going to use them. Don't go back to the x limits. Don't plug in x equal 1 here and x equals 0, because this is not x, this is u. Okay, so now it's just a matter of doing the arithmetic I've done here, find a common denominator, and I get 7/16 as my answer. So again, when you're doing these problems, substitution, right, for change of variables, you need to show your substitution, but you also need to show the change in the limits. Very important. If you write this integral with the old limits of integration, it's incorrect. It is incorrect. It is wrong, and you don't want to do that. Okay, so I hope this is clear in this process. So this is like 54e, but again, all the ones in 54 are very similar to this, just depending on your substitution.